This example, we are going to write the following set builder notation in the first column as an interval using the interval notation in the second column and plot the set on the real number line in the third column. Note that the empty set can arise from a set that defined using the set builder notation. The empty set is a set without the member. So either use the curly bracket, open and close, nothing in there, or the now set symbol. The first example, or part A, the set of x such that 4 is strictly less than x. That means x would be any real number that is higher than 4. 4 is on the lower end, so 4 will be on the left of the interval notation, not including because strictly less than. So we use the open parentheses. Any number greater than, we use the notation infinity for this case. And for infinity, we use the open parentheses. To plot the set on the real number line, locate the number 4 using the empty circle because we don't include the number 4. Draw the line to the right because any x going to be greater than 4. So point the arrow to the right side. So this is the set that represent the real numbers that greater than 4. Part B, the set of x such that x is less than or equal to negative 3. X is lower than negative 3, therefore negative 3 is on the right side of the interval notation. Use the negative infinity to represent the number that lower than negative 3, which is on the left side of the interval notation. Open parentheses for the infinity symbol. We have the less than or equal to, so we're going to include the value negative 3. And then locate the value negative 3 on the real number line using the solid circle. Draw the line to the left of negative 3. Put the arrow pointing to the left that represents the set of x that is less than or equal to negative 3. Part C, the set of x such that x is strictly greater than negative 1, strictly less than positive 2. Negative 1 is lower number, 2 is the higher or greater number. Not including both numbers, we use the open parentheses on both ends. Locate negative 1 using the empty circle as well as the value 2. Draw the line to connect these two circles. Part D, the set of x such that 2 is strictly greater than, x is strictly greater than 2. So 2 would be the left end. And x is less than or equal to 5. So 5 on the right end. Strictly greater than 2. So put the open parentheses on the left end. Square bracket on the right end. Locate the value 2 using the empty circle. Locate the number 5 using the solid circle because we include 5, not including 2. And then use a line to connect these two circles. Part E, the set of x such that x is greater than or equal to negative 3, strictly less than 4, including negative 3, square bracket, not including 4, so open parentheses. Locate the number negative 3 using the solid circle. Locate the number 4, empty circle. Draw the line between these two circles. The last one, the set of x such that x is greater than 1 and x is less than or equal to negative 4. Think about any real number that is greater than 1. For example, the number 5. Is the number 5 less than or equal to negative 4 at the same time? The answer is no. That means this is an empty set. For the empty set, we use the notation as the open curly bracket and close curly bracket, or use the now set symbol, which is the 0 and then crossbar over it. That means no interval notation for that and no set on the real number line for this set in part F. More example involving the set builder notation. In this case, we are going to write a set or the list that's described by the following set builder notations. Part A and part B are very similar. What they have in common would be the properties that x is the integer, x is strictly greater than 8, less than or equal to 12. The difference is we're going to make a list of the x for part A, the list of 3 times x for part B that satisfy the same condition. So in part A, we look at the x as an integer greater than 8. That means we start with the number 9 and keep going with the next integer, which is 10, 11, including 12. Therefore, this set consists of 4 members. In part B, we're going to make a list of 3 times x that satisfy the same conditions. Otherwise, we say we're going to make a list of 3 times each member in part A. So 3 times 9, 3 times 10, 3 times 11, 3 times 12. Another way we said we're going to make a list of 27, 30, 33, and 36 as the list of the members in part B.